Hello everybody and welcome back. Root Beer here. We're going to continue on looking at the 2007 Friar Contest. We've already done questions 1 and 2, and we're on to question number 3. So let's take a look. So, it's split up into 3 parts, A, B, and C. Alright, part A. A number is divisible by 8 if the number formed by its last 3 digits is divisible by 8. It's because 8 is 2 to the power of 3. For example, the number 4738928 is divisible by 8 because 248 is divisible by 8. Okay, it's a nice little divisibility rule. Hopefully you're familiar with it, but if not, that's okay. They'll often introduce new concepts on a paper, so it's something you should be used to if you're going to write these contests seriously. However, 4738928, so all we did was switch the last 2 digits, is not divisible by 8 because 284 is not divisible by 8. So it doesn't matter how big the number is, we just need to look at the last 3 digits. If 992,466,186 is divisible by 8, where A represents just 1 digit, what are the possible values of A? And as usual in this contest, explain how you obtained your answer. Okay. So A is not a leading digit, right? You can't have A be a 0 if it's up front. But A is somewhere in the middle of the number, so A can be anything from 0 to 9. So really we're asked, how do we make this number divisible by 8? Okay, well we're already told we just need to look at the last 3 digits. It was 992... and then a bunch of stuff, and then 1A6. So let's just go back and look at what it was. 466, 1A6. So the divisibility rule says that it doesn't matter about this 992, all that nonsense, we just need to look at 1A6. So A can be anything between 0 and 9. So we have to ask ourselves, okay, how do we check whether or not this is divisible by 8? Well, 1A6 is the same as 100 plus A times 10. I guess I should rewrite that as 10A. But we're just expanding this out based on the rules of decimal notation. So 100s, A10s, or 10As, plus 6 1s. That's what 1A6 means. That's the way our number system works. Okay. Well, I noticed that this is really 106. Sorry, not 104. I'm going to use 104 in a moment. 106 plus 10A. And we see that 8 divides 104. Right? You can double check that on your calculator. It's 13 times 8. And obviously it's going to divide 8A. And if 8's going to divide this, we know 8 divides this, so that tells us that 8's going to divide, well, what's left over. So that's 2 plus 2a. So 8's going to divide this if 8 divides 2 plus 2a. Well, I see I have a factor of 2 here. So 4 divides 1 plus a. Okay? So now I'm looking for what values of a, when I add 1 to it, give me a multiple of 4. So this tells us a can be 3, or a can be 7, and that's really it. If we try 0, we get 1. If we try 1, we get 2. 2, we get 3. 3, we get 4. We want 4. 4 gives us 5. That's no good. 5 gives us 6. That's equally bad. 6 gives us 6 plus 1 is 7. That's not a multiple of 4. 7 plus 1 is 8. That is a multiple of 4. 8 plus 1 is 9. No good. 9 plus 1 is 10. That's no good. And a can only be between 0 and 9. So a is 3 or 7. Right, and I think we were just asked for what values of a, not the number of possible values of a. What are the possible values of a? 3 and 7. And we've explained how we got it. So we put a little statement there at the end. If you wanted to, you could double check these numbers by, if your calculator has a big enough screen, putting in 992,466,176 and dividing that by 8. And that works out just fine. You probably could have manually used your calculator going 0 to 9 and checking all possibilities. But that's not really showing your work. That's sort of proof by calculator. It's also just a bunch of guess and check, which shows that you don't really know the mathematics behind the question. You just know how to use a calculator. And if they made this bigger, if they had, an A and a B here, you would have more than you could handle, and you'd waste time. It's an inelegant solution to just plug things into your calculator. So it's always a good idea to try and use the concepts they're giving you and to use mathematical reasoning rather than just guess and check with a calculator. Okay, B. Looks like we got another divisibility rule here. A number is divisible by 9 if the sum of its digits is divisible by 9. For example, the number 19,836 is divisible by 9. 1 plus 9 plus 8, that's 18, plus 3 plus 6, that's 27. 27 is divisible by 9, so we're set. But 19,825 is not, because 1 plus 9 plus 8, that's 18, plus 2, that's 20, plus 5, that's 25. 25 is not divisible by 9. Okay. So, if D,767,889 is divisible by 9, where D and E each represent a single digit, what are the possible values of the sum D plus E? Explain how you obtained your answer. Okay. So if we want this number to be divisible by 9, then the sum of these digits, D and E, must be divisible by 9. Now, we might want to say, well, D cannot be 0, and that might be an important thing to note, because we can't have a leading 0 if we're talking about a number. But we're talking about sum D plus E, so D being 0 might not really affect us. We might be able to shift it to mean E being 0. Well, let's take a look. D767E89. only if D plus 6 plus 7 plus 6, or sorry, 7 plus 6 plus 7 plus E plus 8 plus 9. So 9 divides, so let's clean this up. So 6 plus 7 plus another 7 plus 8 plus 9. That gives us 37. Yep, 37 plus D plus E. And we just want to figure out the possible sums D plus E. Okay. Not hard to see that D plus E goes between 1. If D is 1 and E is 0, that's as low as it can go. And at best, they could both be 9, so that gives us a total of 18. So we want to know what numbers in this range added to 37 give us a multiple of 9. This number is divisible by 9, and this number is divisible by 9. Their difference will be divisible by 9. So 9 divides 1 plus D plus E. So we're looking for numbers in this range so that when we add 1 to them, we get a multiple of 9. Well, 2 is less than or equal to 1 plus D plus E, less than or equal to 19. So the multiples of 9 between 2 and 19 inclusive are 9 and 18. So D plus E is 9 minus 1, 8, or 18 minus 1, which is 17. And those are the possible values of D plus E. Now there's another part to this question, so let's get ourselves a scrap piece of paper here and take a look at C part. The number 5,418,507,286 is divisible by 72. If G and H each represent a single digit, what pairs of values of G and H are possible? Okay. 72 is 8 times 9. Okay, that's the first thing that jumps out at me. 72 is 8 times 9. Now, why might I go looking for that? Well, we already talked about divisibility by 8 and divisibility by 9. And C is sort of the building things up to all the previous parts. If it's the last question, the previous parts should build up to show you patterns and help you finish the last question. And I also noticed that we're talking about divisibility by 72, but they didn't give us a rule for divisibility by 72. So you put 2 and 2 together, you should be using the previous divisibility rules, and hey, look, 72 is 8 times 9. So we're going to have to flip back and forth a couple times between this and bamboo paper to write down this number properly. But 541G 509, I think it's 2H6, but we're going to have to go back and double check. 541G 507 2H6. Okay. Right, you want to be divisible by a product, you have to be divisible by the factors. As long as the factors have a GCD of 1. Greatest common divisor of 1. Okay. So we need divisibility by 8 and divisibility by 9. And we just want possible pairs GH. Let's double check that before we dive right into the question. You got to read the whole thing so we know exactly what we're being asked for. They're each single digits, and neither of them are leading, so that's fantastic. What pairs of values of G and H are possible? So they can both lie anywhere between 0 and 9. That's fantastic. So I can tackle these in any order. I'm tackling divisibility by 8 first because that will just involve H, and so I'll get a list of possible values of H. That means 8 divides 200 but that's going to be 200 plus 10H plus 6. 8 divides 200. So that means 8 divides 10H plus 6, which is 2, 5H plus 3. Alright. So we have a factor of 2 in that 8 and a factor of 2 right here, so this only works out if 4 divides 5H plus 3. So H is between 0 and 9. So 5H is going to be between 0 and 49. Sorry, not 49, 45. And that means 5H plus 3 is between 3 and 48. So what multiples of 4 do we have in here? Okay, well we have, not all of them are going to work out, but multiples 4, 8, 12, 16, 20, 24, 28. I realize there's another way you could do this, probably with modular arithmetic and invertibility of this 5 relative to 4. Oh, doi. I don't have to do 5H. I can do just an H. So 4 has to divide H plus 3. Here we go. There. So we got a 4, 8, or 12. And that means that H is going to be 1, 5, or 9. Okay, we can double check those. 216, that's divisible by 8. 256, that's divisible by 8. And 296, That's also divisible by 8, giving us 37 there. So we just do a little check to make sure before we move on and try and figure out what g is, that our possible h values all work. And once again, we could also pick a random one, say 3 to 36. That doesn't divide by 8. So we're reasonably confident these are the only ones and we haven't missed anything. Let's just make sure this 5 looks like a 5. Alright. So that's what h is, and that comes from divisibility by 8. Didn't involve g at all, which is why I chose to start with that one. So divisibility by 9, 5 plus 4 plus 1 plus g, not a 6, it's a g. Plus 5 plus 0 plus 7 plus 2 plus h plus 6 should be divisible by 9. So that's 9 divides 5 plus 4 plus 1 plus 5 plus 0 plus 7 plus 2 plus 6. That's 30 plus g plus h. Group those, that's 15 right there, and that's another 15. So yeah, definitely 30. Okay. So we can subtract off 27 from this 30, and we just get 3 plus g plus h. Okay. So we have possible values for h. So if h is 1, actually, you know what? Let's do this on the next page so it's all together. It's nice and clean. Alright. So we're going to flip over. 9 divides 3 plus g plus h. So if h equals 1, this becomes 9 divides 4 plus g. Well, I know g can be anything from 0 to 9. So 4 plus g can be anything from 4 to 13. So we want multiples of 9 in here. Well, there's only the one. That's 9. And that gives us g is 5, h is 1. So that's one of the possibilities. It's the only one if h is 1. What else could h be? H could be 5. So then 9 divided by 9 is a factor of 8 plus g. So 8 plus g is divisible by 9. Well, we know the game by now. G lies between 0 and 9 inclusive, so 8 plus g is between 8 and 17 inclusive. So that gives us g plus 8 is equal to 9. G equals 1. So 1 and 5, that's another pair. Interesting little symmetry there, I like that. And the last possibility for h, if h was 9, then we'd get 12 plus g. So g lies between 12 and 21. Oh, not g, 12 plus g. And there's only one possible value here as well. And that's 18. So g is 6. So we get 6 and 9. So we get 3 possible pairs. GH is 1, 5, 5, 1, and 6, 9. And that was the last thing we had to do in this question. That was C part. So, what pairs of values of GH are possible? We figured out all possible pairs of G and H. And if you have a big enough calculator, you could probably plug in possible values here. And check that, so I'm plugging in G is 6 and H is 9. Check that that is divisible by 72, and, well, the one I checked certainly is. So 6 and 9 definitely a go. You can probably check the other 2 if you want to, if your calculator is big enough. But either way, that concludes the question number 3. So we just have one more question to go on the 2007 Fryer paper. We'll look at question 4 in the very next video. Again, if you haven't had a chance to try it now. Link down below to the contests. And yeah, so thank you all for watching. Hope everything's going well with you, and I'll see you all in the very next video.